Welcome back to our second lesson, and this one is going to our second lesson. There it is. We are going to continue with the hydrocarbon. So we have talked about the general formula, and I showed you that. Now we want to talk about structural formula. So structural formula, we have two types of structural formula. We have open structural formula and condensed structural formula. So structural formula is just going to show the structure. It's going to show the structure of how given hydrocarbon. For example, propane has 3. So what we are going to do here, Cn, remember the formula CnH2n plus 2. So that means propane being 3, C3, then H2. So H is 2 times 3 plus 2, which is 8. So what we are going to do here, start 1, 2, 3. So the easiest way to do this, just draw the number of carbon atoms. After drawing the number of carbon atoms, then fill in with hydrogens. Now, we will end up with 3 carbon atoms and 8 hydrogen. Let's see. 1, 2, 3. Then how many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8. 4 alkanes will come automatically. And another way you have to ensure that each carbon atom is surrounded by 4 bonds. For example, this carbon atom is surrounded by this one. 1, 2, 3, 4. This carbon atom is surrounded by this bond. 1, 2, 3, 4. This carbon atom is surrounded by how many bonds? 1, 2, 3, 4. So each carbon atom has to be surrounded by. Now let's say we are talking about heptane. Heptane has got 7. So that means C7. 2 times 7 will be 14 plus 2, 16. Now, 1, 2, 3, 4, 5, 6, 7. So, H, 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 Now, if you count these H, they have to be 60. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now, each carbon is surrounded by 4 bonds. Each carbon atom. So, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So you find that each carbon is surrounded. That's why it's called tetravalent. Type that tetravalent. It has to be tetra means 4. Each carbon has to be surrounded by 4 bonds. Inside that, if you end up with something like this, even if you count the hydrogen is 15. And this one will have how many bonds? 1, 2, 3. That means 1 bond is still there. Or maybe you can have it here, like it. If you put it this way, this will be lacking one bond, this one also will be lacking one bond. So this structure or formula is just showing how the structure of that particular hydrocarbon. How have you arranged your hydrogens and carbons? So when you are told to write the structural formula, then you have to do that. We'll still come back here. Now, since carbon is tetravalent, each atom in the carbon in the alkane must always be bonded using 4 covalent bonds. Actually, that's what I was explaining. Each carbon has to be bonded using 4 covalent bonds, 4 shared pairs of electrons. Shared pair, that means, according to structure and bonding, this is what it means. So that's how it is, like that. So that is what it means. Now, going, since hydrogen is monovalent, each atom of the hydrogen, so as I told you, hydrogen is monovalent. That means only this one is stable. And this is the same as CH, H. Now this is the structure for methane. This is the structure for methane. Now, one member of the alkane differ from the next one, or the previous by CH2. Now, what we are going to do here, I want to show you how this CH2 is coming in. These are how many? 1, 2, 3, 4, 5. Then we go to 6. 1, 2, 3, 4, 5, 6. Yes. Now, this carbon is surrounded by 3 hydrogen. 1, 2, 3. CH3. This carbon is surrounded by 2 of them. This and this. Can write CH2. This one is surrounded by 2 of them, this and this, CH2. Then this one is also surrounded by 2, CH2. This one is surrounded by, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this one is surrounded by 3. The last one is surrounded by 3. So this one is surrounded by 3, surrounded by 2, 2. The next one is having 6 carbon. 1, 2, 3, 4, 5, 6. Now this one is surrounded by 3, CH3. This one is CH2. This one is CH2. This one is CH2. This one is CH2. And this one is surrounded by 3 groups. Now, we want to compare the number of CH of this one and this one. Now, if we get rid of this, one is this. This one is this. This one is this. This one is this. Okay. But this one will be this. But this one will remain handy. So, if we are to compare the next one, this one has got 1, 2, 3, 4, 5, 6. If it was having 7 to be CH3, 2, 3, 4, 5, 6, 7. This one will have one extra CH3, CH2, sorry. And this one has got only 1, 2, 3, 4, 5. This one will be CH3, we'll have 4 of them, CH2, CH2, CH2. So this will have 4 carbons. So this will go with this will go with this, we have to take this one extra. So in other words, they are different. The previous and the next differ by what we call a CH2. And this is what we call homologous series. They form what we call an homologous series. And the formula for this homologous series is what we have. The formula for homologous C and 2N. Now, one member of which are propane differ from ethane by one carbon and 2 hydrogen atoms. Now, ethane differ from methane also by, so that is how. But as we are going on, we are going to have more and more inside. A group of compounds that differ by CH2 group from the next or the previous consecutive is called homologous series. Now, homologous series differ by CH2 group from the next or previous consecutive, have similar chemical properties. That means methane and ethane, they have similar chemical property. Now, how similar chemical formula that can be represented by general formula is this one. CH2, Cn, that one. The physical properties differ. They show gradual difference in physical property. We begin with gases, then we go to liquid, then we go to solids. So as you go down the group, there's an increase in melting and boiling point as the relative molecular mass increases. So it shows a steady gradual change. The first 4 alkanes have prefix meth, eth, like I've already shown you, meth, eth, prop, and but represent 1, 2, 3, and 4 carbon compound. All other use the numerical prefix pent, x, f, as already shown you in our previous. If one hydrogen atom in alkane is removed, then it's going to form an alkyl. An alkyl group. Now let me just show you alkyl group. Then we are going to stop there, such that just the name. So like we have prefix met, then we have eth, then we have prop, then we have but, then we have ent, then we have x. Let me stop there. Now alkyl group. Now it also have an alk plus I. So this is the alk part, then we have I part. So this one will become methyl. Then you add I. This one becomes ethyl. This one becomes propyl. This one becomes butyl. This one becomes pentyl. This one becomes. And how do I achieve this? You just remove one hydrogen. For example, we have methane. We have C. So this methyl. Methyl, you remove any of this, becomes like that. Suppose you have ethane. This is the last example, ethane, which is that one. Ethane has got 6 hydrogen, but when you come to ethyl, you are going to remove any of this, only one. Hydrogen, 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 hydrogen. Now suppose you choose to remove this one, you don't put it. So that is how. So we are going to pick from here next time so that we can continue. Thank you. Have a good day.